Hello guys, welcome back to Edutainment. Let's embark on Aditya L1. ISRO's new mission is for the Sun, to the giant that powers our solar system. India's first solar mission, Aditya L11 will be launched on September 2nd at 11:50 am from Sriharikota Spaceport. This is India's first ever space solar observatory spacecraft, the spacecraft Aditya L1. It will be traveling 1.5 million kilometers from the Earth to the Lagrange, one point between the Earth and the Sun. Now this distance is 4 times the travel by the Chandrayaan missions. What are Lagrange points? Lagrange points are stable positions in space where the gravitational forces of two large bodies, like the Earth and the Moon or the Earth and the Sun, balance the centripetal force felt by a smaller object, such as a satellite. There are 5 Lagrange points, labeled L1 to L5, and they offer ideal locations for spacecraft and observatories to maintain relatively fixed positions relative to the larger bodies, making them useful for various space missions. This means that spacecrafts placed at L1 points do not need to use a lot of fuel to remain in position. The velocity of the spacecraft around the Earth will be increased till it is slingshot towards the Sun. The distance to the L1 point will be nearly covered in 4 months. The spacecraft will then be inserted into a hollow orbit around the L1. It will collect data for a span of 5 years. It is designed to provide remote observations of the solar corona, the outermost layers of the Sun, and in 2 observations of the solar vent while its stay at L1. The other one mission will see the Polar Satellite Launch Vehicle PSLV carry the 1,475 kg spacecraft, a total of 1,800 kg rocket into an elliptical orbit around the Earth. Importantly, it might provide clues to scientists about a generational mystery: how the temperature of the corona reaches about 1,000,000 degrees while the Sun's surface itself stays around 6,000 degrees Celsius. It is to get a deeper understanding of the star closest to us and how its radiation, heat and magnetic fields affect us. Objectives of the solar mission: coronal heating and solar wind acceleration, coupling and dynamics of the solar atmosphere, solar wind distribution and temperature anisotropy, initiation of coronal mass ejection, CME, flares, and near-Earth space weather. Uniqueness of Aditya L1, first time spatially resolved solar disk in the near UV band. CME dynamics close to the solar disk, from 1.05 solar radius, thereby providing information in the acceleration regime of CME, which is not observed consistently. Onboard intelligence to detect CMEs and solar flares for optimized observations and data volume. Directional and energy anisotropy of solar wind using multidirection observations. A satellite placed in the hollow orbit around the L1 point has the major advantage of continuously viewing the Sun without any planets obstructing the view or causing eclipses. This will provide a greater advantage of observing solar activities and its effect on space weather in real time. Now, using the special vantage point, L1 with 4 payloads will directly view the Sun, and the remaining 3 payloads are expected to carry out in situ studies of particles and fields at the L1 point visible emission line. Corona graph is designed to study solar corona and dynamics of coronal mass ejection. Solar ultraviolet imaging telescope to image the solar photosphere and chromosphere in near ultraviolet, and to measure the solar radiance variations in near UV. Solar low energy X-ray spectrometer, high energy orbiting X-ray spectrometer are designed to study the X-ray flares from the Sun over a wide X-ray energy range. Aditya Solar Wind Particle Experiment and Plasma Analyzer Package. For Aditya Plasma Analyzer Package for payloads are designed to study the solar winds and energetic icons as well as the energy distribution. Magnetometer payload is capable of measuring interplanetary magnetic fields at the L1 point.